Hey guys, this is lesson 12.5 and 12.6. Now, for notes, you don't have to write all of this. It'd be way too much to write down. So just write down the main key things. The independent events, the highlighted word, the key concept, and an example. So it says, suppose the numbers from 1 to 10 are written on 10 cards, one number to a card. You are interested in drawing one card at random and getting an even number, and then drawing a second card, getting an even number. If you replace your first card, the probability of getting an even number on the second card is not affected. So by replacing it, it becomes an independent event. One does not rely on the other. So write down independent events are events for which the occurrence of one event does not affect the probability of the other. So this is with replacement. So here's what it looks like. The probability of an event is the probability of the first event times the probability of the second. So here's an example. You roll a number cube once, then you roll it again. So here's my number cube. Okay, and it has, let's say it's a 3. It's a dice, whatever. Okay, I have my number cube. What is the probability that you get a 2 on the first roll and a number greater than 4 on the second? So the probability of a 2 on the first roll and then the probability of a number greater than 4 on the second roll. So probability of 2 would be 1/6, because there's 1 out of 6, times the probability greater than 4. My only options there are the numbers 5 and 6, so that would be 2 out of 6. So I multiply those together. 1 times 2 is 2, and 6 times 6 is 36. So I would get, and then I simplify that to 1/18. Now, a dependent event, okay, is suppose you want to draw a card, and you draw one card and you keep it in your hand. You don't replace it. So what's the probability of drawing the second even card? It would be affected because you'd have one in your hand already. So dependent events are events for which the occurrence of one event affects the probability of the other. So this is without replacement. So now, here's the key concept. What you want to do is to find the probability of A, then B. You first find what A would be, and then you find what B is after A. So here's an example. 3 girls and 2 boys volunteer to represent their class at a school assembly. The teacher selects one name and then another from a bag containing the 5 names. What is the probability that both representatives will be girls? So the probability of first drawing a girl would be 3 out of 5. 3 out of a total of 5 kids. There's 3 girls' names out of 5 in that bag. So then the probability of selecting a girl again, now this time it'd be different because I already have one girl in my hand, one name. So if I reach into the bag, there's only 4 in the bag and there's only 2 girls' names left. So it would be 2 out of a total of 4. And then I multiply those together. Notice that it went down by 1 because I'm carrying one name in my hand. So the numbers go down by 1. So 3 times 2 is 6, and 5 times 4 is 20. 6 over 20 is 3 over 10. So 3/10 is the probability that you'd pick 2 girls' names. Okay, that's it for 12.5. Now you need to watch the 12.6 video.